Hello students, let us understand about scalar and vector quantities. Now physical quantities can be divided into two groups. One is scalar and the other one is vector. Let me tell you a little about these scalar and vector quantities. Scalar quantities. Now we know that to represent some kind of physical quantities like mass, length, time, density, speed and so on, only magnitude, that is the unit, and the numeral value, like for example 5 kilogram. 5 is the numerical value and kilogram is the unit, so it describes only the magnitude. And so those physical quantities which have only magnitude and have no direction are called scalar quantities. I hope you understand this. Scalar quantities have only magnitude, and magnitude refers to unit and the numerical value. The example that I gave you, 5 kilogram of rice. Okay, so 5 refers to the numerical value and kilogram refers to the unit. So this is a magnitude of a physical quantity and this is a scalar quantity. Let us understand about vector quantity. Now those physical quantities which have both magnitude and direction, they are called as vector quantities. In simple words, a vector quantity has magnitude as well as direction, like displacement, velocity, acceleration, force, weight, moment, momentum, and impulse are some of the examples of vector quantity. Just to make you understand it much better, let us say I have to go 7 kilometers north. 7 kilometers north. What does this mean? That I need to move 7 kilometers north, right? And 7 kilometer is what? It is the magnitude. And I told you a while ago that magnitude has the numerical value and the unit, right? 7 kilometer. And there is something else added here. I have to move north. So what is north? It is a direction. So whenever there are both magnitude and direction, all right, to describe a physical quantity, then we should understand that it's a vector quantity. I hope you have understood this. Let us understand about distance and displacement. The actual length that is covered by a moving body is called distance. I would like to repeat it. The actual length covered by a moving object is called a distance. For example, I want to go to Bagdogra or I want to go to Siliguri, right? From here, the actual distance that would be covered will be 11 kilometers or 20 to 25 kilometers, right? So that is the distance. Now the other one is the displacement, the shortest possible distance covered by a body between its starting position and final position. You can see on your screen what's a distance and what is a displacement. Okay, just a quick review. Distance is the total length traveled, the actual length traveled, okay, by a moving body, and displacement is the shortest possible distance, so shortest length covered by a body between its initial and final position. And now displacement is always the straight line path between the initial and the final. You're traveling, or when you're moving, the road can be curved, right? But when we take a point from the initial position to the final position, not taking the curved paths, that distance is known as displacement. You can see on your screen to understand it. much better. I would like to give you an example. The athlete takes a separate curved path to reach the monument while the couple walk along the straight road. Note the following, okay? The first one is the athlete walks a greater distance than the couple, right? Let's say walking 40 meters. On marching the monument point B, the distance of the athlete and the couple from point A is the same, 30 meters. The third point, the distance covered by the athlete is 40 meters. The displacement of the athlete from its original position is 30 meters. Point number 4, the distance covered by the couple is 30 meters. The displacement of the couple from their original position is also 30 meters. Let us understand about speed. Speed of an object is the distance traveled by it in unit time. Okay, distance traveled in a unit time. That's why the formula of speed is distance traveled by time taken. Okay, like suppose a motorbike or a car travels a distance of 100 kilometers in 4 hours, then the speed of this car will be, speed is equal to distance by time. Distance is how much? 100 kilometers divided by time, that is 4 hours. So the speed of this car or bike will be 25 kilometers per hour. Now the unit of speed depends on the unit of distance and the unit of time. You have to be very careful when you're doing numerical, when you're calculating. Remember that this unit of speed depends on the unit of distance and unit of time. There are two units of distance that we take, meter and kilometer. Okay, and there are two units of time that we take. One is hour and the other one is minute. Okay, I hope you have understood this. The physical quantities, there are two types of physical quantities. You can see on your screen. We have already learned about it. Scalar quantities and vector quantities. And the examples of scalar quantities are like mass and length, and vector quantities, velocity and weight. And we have already talked about what is a scalar quantity. Scalar quantity has only magnitude, and vector quantity has both magnitude as well as distance. I hope you have understood this.